Okay, Bismillahirrahmanirrahim. Let's go back to the notes. So we are continuing where we left off. So last week, just to do a quick recap, we were discussing which, like when we have an expression like this, when we have something that looks like this, what do we do first? Okay, what do we do first? And then we mentioned about BODMAS, which should be familiar to you. It's something that you would have done in primary school. So we attempt to do the bracket first, or division, multiplication, and then finally addition, subtraction. And all of this is left to right lah. Okay, so we do this bracket first, we get this, and then remember what I said, when you have a cube root of a negative number, you will still get a negative number. But if you were to have, can you have a square root of a negative number? Tak boleh. You cannot have a square root of a negative number. So square root, or the question shows you a square root of a negative number, most likely there's a typo. There's a typo. Or when you get to higher level, if you yourself, when you are square rooting, you square root a negative number, your answer will be no solution. No solution. SOLUTION. That means to say that there's no answer. In maths, this can happen. You can have instances where you do not have an answer. Or no real solutions. That one will involve knowledge of the different types of numbers. Okay, you notice that so far we've been talking about real numbers, right? Real numbers. So I don't know whether I mentioned in this class, the opposite of a real number is an imaginary number. Okay, that one only when you get to JC or Poly, then you will talk about it. Okay. Any questions with regard to question 9? Or are you very clear on this? You're clear, okay. So for instance, let me show you this. So this one you see, there's no bracket, right? So when there's no bracket, your minus 2 square becomes minus 4. I think I mentioned to you, if there's a minus 2 with a bracket, the negative becomes positive. Minus 2 bracket square is 4. But minus 2 square without the bracket is minus 4. Okay? So now when I have square root 49, this will give me 7. This will give me 7. Now, where did this 15 come from, Shafi?
3 times.
Yeah, the negative 3 times the negative 5 is positive 15. This in itself is positive 15, but you have a minus here, that's why it becomes minus 15. Okay, so 7 minus 15 is negative 8. Negative 4 minus negative 8 is negative 4 plus 8, so this gives me 4. So they are asking you in question 10 to check this using a calculator. So can you go ahead, take out your calculator and check, and then see whether your answers for A, B, C, D, are they the same with the previous A, B, C, D? Can you do that now? So it's also a skill in mathematics to be able to use the calculator properly. Done? Error. Okay. Can you check again to see where you went wrong? Okay, so can you tell me where is the question with the error? A. So did you happen to put cube root or square root? This is your error. Can you see that your square root is very long? It's going over the whole thing. So that's why you have an error. So you need to be square root 81. If you continue typing, the square root will continue to extend. So what do I need to do here? I need to press this arrow to escape the square root. Then minus 2 times bracket square root 100. Again, press the arrow to escape the square root. If not, the square root will continue to extend. Because sometimes the reason the calculator allows you to do that is because sometimes you might have a lot of terms inside the one square root. Like B. See B? So B, you can see the square root is throughout the whole thing, right? Minus cube root negative 1000. So all these you have to be very careful. Again, press the arrow to get out of the cube root, put a square, put a bracket there. Okay, so this is negative 31. Is the previous answer also negative 31? Check.
You go through the answer. Yeah.
Good, negative 31. Okay, good. Okay, come try for so for question 10, I don't need you to give any working. You just check. This is just to test you on how well you can use the calculator. What's that? Which one? B. Okay, come. Okay, so where is your mistake? Okay, looks okay. 3 square minus 10 minus 6. Okay. So, do you press equal?
Yeah.
Try it. What is it previously? Is it the same? Baca lain kan? Different lah. There's a typo. Okay, so can you change the minus here to a times? Yes. So it's not an error on your part, it's an error on the question itself. So sometimes you have to be mindful of mistakes that your teachers or your tutors might make, because we are all old folks. We're gonna die very soon. So we need to have people check on us, the youngsters. Okay, come, Shafi, try the one with the times. How old are your parents? You don't know your parents?
I know, but I forgot. I think my mother's 47, my father's 46.
Today you go home, you must know your father punya birthday, date, month, year. Can or not?
You know that I don't know exact age.
So calculate lah. When was your father born? What day, what month, what year? You don't know your father's birthday?
I know my father's birthday.
Okay, what is your father's birthday?
8th July.
8th of July. Okay, so the 19 is 19 what? 1980 or 1979 or 1982 or 19 what?
Yeah.
Really. Brother, you put in the same thing again. Change the minus to a times.
I did.
No, it's not. It's minus that. This minus, you need to change to times.
Oh, yeah.
Tell you like still in holiday mode. Why?
It's not early morning. I went for football match.
I tell you, football is the beginning of the end. Once you join football, your academics all that was out. I tell you, I've never seen a boy very good in football, then the results also all pass. Never see before. Maybe if he's like me lah, wear glasses, then you pass me the ball also, I like, then maybe I study, I can get all A. But if he's the skillful kind, right, habis. confirm. God is fair. Lah. God is fair. You know the meaning God is fair. Because it cannot be you are very good in football and you are very good in your studies also. It's not fair, isn't it? So if you are so from your exam results, I can tell you whether you are good in football or not. If your exam result very lousy, right? That means I'm sure you are a fantastic footballer. But if your exam result very good, right? That means I know, oh, this guy kaki bangku lah. He cannot play football. Okay, so now do you get the answer?
40.
Okay, yeah, the answer should be 14. Come, we must do this quickly, no? This one is like, we're taking very slow to do this. We're taking a lot of time to do this. Come, see. You must like, like those Chinese students use the all this. How you play a video game like that, right? The calculator also same as quickly one. Come, see where you get 64 and 4. Football, so I ban my child from playing football. Because Singapore football no future. That's the honest truth. Correct. And then D, fast. This one the -2, there's no bracket. Your calculator got a machine. Everybody knows the real star at Barcelona is Luis Suarez. But you put Messi on him. Oh. Okay. So this is a categorization of all that we have learned. So then this one is your imaginary numbers. Remember just now I spoke about it. So this will be taught after secondary school math when you go to, if you manage to go to JC or if you manage to go to poly course with engineering, then you will cover this then. But for now, this is your concern. Real numbers can be either rational or irrational. Do you know the difference? I think I did mention to you. Did I mention to you? No. Okay, so rational numbers, they can be put in the form of a fraction. Irrational numbers, they cannot be put in the form of a fraction. So if I take my pi, you take out your calculator, you press pi, pi. So pi equals to? Is 3.14 is an approximated value. This is the actual value for pi. And in fact, it goes on for very long. It can go on for thousands and thousands of numbers. So if I want to change this to a fraction, cannot. It will not be 22 over 7. 22 over 7, 3.14, all these are approximations. Not the exact value. So these are known as irrational numbers. So for your rational numbers, you have integers, you have fractions and decimals. Integers, there is no fraction, there is no decimal. It's like whole numbers. It's like whole numbers. Okay. So let's talk about this. So now we are talking about 4 operations, 2 fractions. Okay. So never mind lah. I think I don't want to explain. Just without using a calculator, find the value of each of the following. Okay. Come, let's try this one. Okay, so we do together. Firstly, I do together with you. After that, I will ask you to do on your own. Okay, so what is my first step here? My first step here is to change everything to improper fraction. Improper fraction. So 3 times 9, 27. 27 plus 2, 29, right? So this will be minus 29 over 9 plus 7 over 36. Here I can do something. What do I do with the minus and minus? Plus 11 over 18. Okay, next thing, what must I do, Shafi? There is addition here. The denominators are not the same. What must I do? Good. For addition and subtraction, I must make the denominators the same. So times 4. For here, I times 4. For here, I times 2. So times 4, okay, 29 times 4, 30 times 4 is 120, right? 30 times 4 is 120, so 29 times 4 is 126. All this you must, 116, sorry. All this you must be able to do lah. But if you can't, then might take out your calculator. It's okay. It's not haram. You can use your calculator here. You can take 29 times 4, just to confirm, 116. But they expect you to do all this without a calculator. This one, what must I do? Times what? 18 to change to 36, what must I do? All these mental sums, times 2, very good. So 11 becomes 22. So this is, now what I'm going to do, minus 116. Minus 116, because there's a minus there. Do with me together, minus 116 plus 7 plus 22. Do you get minus 87? So minus 87 over 36. Must I leave my number as, can I leave my number as an improper fraction? Can, no problem. You want to change it to a mixed number? Also can. So if you change to a mixed number, you just key this into your calculator. You will get, how do I do this? Minus 2, 5, and 12. Okay? Can? So actually, what do they mean by without using a calculator? They mean to say that they want to see you perform these steps here. And this is the whole idea of them saying without using a calculator. Because of course, your teacher is not going to come to you in the exam and physically check whether you are using the calculator or not. They're not going to do that. So use the calculator to help you in certain parts, but you cannot use the calculator to give you just the answer. Because some students, I don't know why they're so silly. They say without using a calculator, they still go and key in everything and then just give the answer. Cannot lah. Once you just give the answer like that, I will mark you wrong. Even if your answer is correct, you will be marked wrong. Okay, so now do for me B, C, and D. B, C, and D. So focus on the working here. And then your board mass. I think D, never mind. D do it as homework. Just B and C, please. Because we are running short of time. Let me know once you're done B and C.
C.
Okay, come, let's go through B first. So for B, we can probably tell that we need to change the denominators to 12. Okay, so we have 13 over 12 that can remain as 13 over 12 minus, okay, let's work out the bracket first. Minus, so this one instead of 12, instead of 4, sorry, we change it to 12. So this will be 33 over 12 minus 14 over 12. Step by step. Okay, and then now we have 13 over 12 minus, so this is where you can use your calculator, minus 33 minus 14. So just like, I mean, the way to do it, I would, for me personally, I just focus on once I've changed the denominators to the same, I just focus on the number on top, and then I look at the signs. So minus 33 minus 14. So this will be minus 47. So that's my way of doing it lah. Okay, and then now I open up the bracket, I get 13 over 12 plus 47 over 12. Did you manage to do this? Or did you make a mistake? Okay, so this is 60 over 12. 60 over 12 is 5 whole. Okay, so where was your error, Shafi?
33 minus 40.
Yeah, it is 33 minus 40. Oh, you forgot the minus in front. Oh, I see. So 33 minus 14, that gave you 19. Okay, so that was your mistake. All right. Okay, let's do C together. You want to take a photo or copy this down or whatever? Okay. Okay, Bismillah. So let's do C. So C, we have 5 minus 1 quarter divide by, again, we're going to do this one first. So what is 1 over, what is half to the power of 3? So when you have a fraction to the power of something, you need to take the numerator to that power and then the denominator to that same power. So 1 to the power of 3 is 1. 2 to the power of 3 is... No, not 1 times 3. 1 to the power of 3 is... What is 1 to the power of 3? 1 times 1 times 1. If 1 times 3 is 3, isn't it? Yes, cube lah. This is cube. So when you see power 3, that means this is cube, not cube root. Cube root is when you try to do the reverse. The reverse of cube is cube root. This is cube. So 1 cube is 1 times 1 times 1. 2 cube is 8. You with me? 2 cube is 8. And then times, okay, so this one times this. So again, we should do from left to right, right? So let's do that. So 5 minus 1 quarter times 8 over 1. I hope you have not forgotten this from primary school. So you know when you change the divide to times, the fraction must flip. KFC, correct. Times minus 8 over 9. So 5 minus 1, 2. So this is 2 times negative 8 over 9. Why am I keeping it in the bracket? Because there's a negative number inside. Okay, so 5. Do I do 5 minus 2 first or do I do 2 times negative 8 over 9 first?
2 times.
Yes. So this will be negative 16 over 9. Do you know why it's 16?
16.
16. Do you know why it's 16?
Oh.
Because 2 times 8. What is this thing like that? Because it is 2 times 8. Thinking there on someone's speak. So you remember, right, in primary school you were taught something like this. Like for instance, let's say I have 1 times 3 quarter. Or not 1, let's say I say 4 times 3 quarter. 4 times 3, 12. 12 over 4 will give you 3. Or you can think of it as 4 times 3 quarter is cancel, 1, 1, 3. Okay? Okay, so now 5 plus 16 over 9. 5 plus 16 over 9. This will be 5 plus 1 whole, 7 over 9, equals to 6 whole, 7 over 9. Okay, so you are expected to do these kind of questions now that you are in Sec 1. Okay, we have half an hour until our test. Okay, so D do it as homework. Okay, decimals. All right, so decimal. Let me see. Is decimal tested or not? If decimal is not tested, I don't go through yet. Okay, decimal is not tested, so I will cover this next week. I'll cover this next week. So decimal. Actually, I can ask you to do it as homework lah. Okay, so you do the decimal questions as homework. Homework label lah. Homework question 12, question 13, homework. Okay, and then we'll go through the homework next week and we'll finish up question 14 and 15. Okay, why don't you take a quick toilet break, 5 minutes, and then we are going to go into revision of these prime numbers. Okay, yeah, so we will go through this at 1:05. Can 3 minutes. You watched the game or you were playing a game? You were playing. This is what academy. What? What's that? Yeah, like it's an academy, yeah. No. What's the difference between club and academy? It's an academy. Oh. How long have you been playing with this club? Okay, it's 1:05. Let's go into this. So did you manage to read through this set of notes? Notes one. This doesn't look good. Okay, so this will be tested. This will be tested, and I did not manage to go through this with you. Hence, I told you to go home and revise this. Okay, anyway, very quickly now, let's look through this. So, we spoke about this in notes 2. Real numbers are made up of rational numbers or irrational numbers or n irrational numbers. So, irrational numbers cannot be expressed in the form a over b. So numbers like this, square root 2, square root 3, pi, you cannot express them in the form of a over b. Rational numbers, you can express them in the form of A over B. Does it mean that they are always A over B? No. So for instance, the number 5. Is this a rational number or an irrational number? Rational, because 5 can be written as 5 over 1. So if it can be written as 5 over 1, it is therefore rational. It's a rational number. But where under rational numbers do you group this? No. So 5. Under rational numbers, you have integers, you have fractions and decimals. So where does 5 belong?
Rational.
Yeah, so under rational, you have this, you have this. So where do I put the 5 now? Do I put here or do I put here? Integer. 5 is an integer. Okay, so to know what an integer is, you must know what an integer is not. Like I ask you, what is a boy? A boy is not a girl. So if you know what a girl is, you know lah. Anything that is like that is not a boy. So an integer is not
Fraction. And decimal.
So now you know what an integer is?
Yes.
Because when you say whole numbers are only 0 and positive. But you have this thing called negative numbers. Negative numbers, technically you cannot call a negative number a whole number. Can see the categorization now?
It's not.
Yeah. So 5. So what do you say 5 was just now? You said whole number. Okay, actually I wanted to ask you, is 5 an integer or is 5 fraction and decimal? So the correct answer between those two is integer lah. Integer is basically whole number and negative numbers. So as long as an integer is not a fraction, an integer is basically not a fraction and a decimal. But to say that integer is whole number is not correct. Dia macam, okay, let's say boys and girls, right? Then boys who support football, boys who don't support football. So can I automatically say that, oh, you are a boy who supports football? No lah, because there are some boys who don't support football. Okay, but they are boys. Okay, so basically a 5 is an integer. If you want to go deeper than that, a 5 is a positive whole number. A 5 is a positive whole number. Now, if you want to go further deeper than that, amongst the positive numbers, you have 1, you have, read this out for me, and you have composite numbers. Composite numbers. Okay, so what is a prime number? What is a composite number? That would be the bulk of this topic. So the bulk of this topic is talking about prime numbers. So a prime number is a whole number that has exactly 2 different factors. Can you cancel out that exactly 2 again? I think in the notes there's a bit of a typo. So a prime number is a whole number that has exactly 2 different factors. 1 and itself. So what is an example of a prime number? All these things that I've written in pink here. There's more lah, dot. That's why dot means there's more. Okay, so example 2, 5, 1, 0, 3. Why? Because they only have 2 factors.
Cannot divide. You can't divide away.
So can I take 5 divided by 2? Cannot, right? But can I take 5 divided by 1? Can. Can I take 5 divided by 5? Can. So how many factors does 5 have? 2. Hey, you wash your face. I look at you. I don't think anything is going in. Go, do some jumping jacks or something. Can, Shafi? The toilet is it. Can I take, because if you're going to sit on the chair the whole time, I don't think
Oh, you push it.
Is
A little bit messy ya.
okay, no worries. Yeah, you want to pay it?
Aku takut kena kau punya phone.
Oh, tak kisah. Thank you so much, Arif. Tak usah.
1 million people lah.
Allah Akbar. Oh, ke sana mana yang take kami ya Allah, ya. On a Sunday especially.
But surprisingly,
Ah,
it's not as bad as it was.
As it was when last week,
Like,
during December.
Ramai gila lah.
Ramai gila ya.
Still I dare to wait too long.
Okay.
Honestly.
Kau tak pernah try main LAN dekat sana? I heard the LAN is quite nice. Dekat Pasar Tiga ni.
Situ banyak kan.
Yeah.
Dari Lampuri tu najis lah. Tapi
Yeah.
Perform okay je.
Oh,
Ini sama kami yang bouncy kan. Bouncy is like 10 times better lah.
of course
As
lah.
compared to everything.
Kau
Not like
Malay eats, kau kena makan dekat kebab cik. Aku orang-orang buat.
kau yang nonton.
We should go lah one of these.
But nan, pada aku tempat ini ni nan banyak tu sekarang.
Yeah.
So, tapi buat tak tahu.
Okay, bro. Thanks for the coffee. Okay, so you understand now what is a prime number? Okay, so I'm gonna read out some numbers. You tell me whether these are prime numbers or not. -15.
Not prime number.
Why not prime number?
Okay, divide by 3.
No, that's not the reason, because it's negative. So a prime number, you can see over there, is under the positive numbers. So the moment I say negative something, -2, not a prime number. -3, not a prime number, because negative. Okay, 1. Is 1 a prime number?
Yes.
No, 1 is not a prime number.
Why
Okay.
is not a prime number? It's only can divide by one number.
1 only has 1 factor. Prime numbers have at least 2 factors, or prime numbers have 2 factors. Exactly 2 factors. A prime number has exactly 2 factors, so 1 is not. Okay, so 1 is not a prime, 1 is also not a composite. That is written here. 1 is neither prime nor composite. So composite is basically the opposite of prime. Okay, 19. Is 19 a prime number or composite number or what? What is it? What is it? 19 is a prime number. Good. 22. Composite. Okay, good. Okay, so we understand. So what is prime factorization? Prime factorization is this process where you try to break down a composite number into its prime factors. Okay, so every composite number can be broken down into a bunch of prime numbers.
Prime number can only be odd besides 2.
Yes, very good observation. Yeah. So besides 2, all other prime numbers are odd. Okay, and then when you have a composite number, you can break it down into these prime factors, they call it. It's called prime factorization. So to obtain prime factorization, we can use a factor tree or repeated division. So these are the 2 methods that you use in prime factorization. Now, what is index notation? So when I write it like that, this is not index notation. This is not. This is not. What is index notation when I write it like that? Because why the 3 here is called the index. So it's like the power lah. So when I say index notation, that means I want to see the power. So 5 to the power 3. This is index notation like that. So basically you need to be able to do this. If I give you 50, you must give me this. Okay, so now I'm going to teach you the method to get you this. Okay, so this is take a photo of this. These are all the prime numbers from 0 to 100. So take a photo of this, go home and memorize it. You need to know all your prime numbers from 0 to 100.
The one circle is prime number.
Yes, the ones that I circle are the prime numbers. Done? Okay. So now we are going to go into this thing called prime factorization. So we use this number 84 here. So I am going to teach you the repeated division method because I think right now with the time that we have, we don't have time to go through the 2 methods. So you just focus on repeated division. Okay, what are we doing here? So you have 84. You are supposed to divide it by the smallest prime number you can. So what is the smallest prime number here? 2. But if I have, let's say I have a number like 27.
27.
If I have a number like 27, can I divide it by 2? Cannot, right? So I must divide it by 3. Good. So example, this is 84. I divide it by 2. Divide it by 2, I get 42. 42 again, I can divide it by 2. I get 21. Now, 21 cannot be divided by 2, so I divide it by 3. So I do the next bigger prime number. So 21 divided by 3, 7. Now 7 cannot be divided by 2, cannot be divided by 3, cannot be divided by 5, You see how I'm going? I go to the next bigger prime number. But can be divided by 7. So 7 divided by 7 will be 1. Once I get 1, hooray, I'm done. Win already. So the thing is 2 times 2 times 3 times 7. So you can take out your calculator. You can try. Okay, 2 times 2 times 3 times 7. 84. Cantik. That means I did it correctly. So I'm putting it here, but I put it in index notation format. So you see, the 2 is not 2 times 2, it's 2 power 2. Can you see that? 2 power 2. 2 power 2 times 3 times 7. Or if you want to write it like this also can lah. But if the question tells you to give it in index notation format, then you must do it like that. Okay? This is basically the easiest part of this topic. Now we're going to go into something much harder. Okay, so okay, all these the practices that we did in class with the other students. Okay, perform prime factorization. So you can see lah, 980 divided by 2, 490 divided by 2, 245 cannot divide by 2, cannot divide by 3, divide by 5, 49. 49 divided by 7, 7. 7 divided by 7, 1. Okay, then 1560 did the same thing. Okay, can? Any questions? No. Okay. Determine whether each of the following is a prime or composite. Okay. So here, since 218 can be divided by 2, hence 218 is a composite number. So this is a bit of explanation. 227 is not able to be divided by any other prime numbers. Hence 227 is a prime number because its only factors are 1 in itself. Okay. Good, this person who took over me that time. So since it is able to be divided by 5 here, 605 is a composite number. So sometimes the question will be like that. The question will give you a number and then ask you, tell me whether this is a prime number or a composite number. Okay? So you need to be able to... Why the answer so long? Welcome to secondary school, my friend. But this is secondary school. You have to show the teacher that you're smart. You have to show the teacher, see, I can, I can give you my proofs, my, all this. See, I know, honestly, this is maths in secondary school. That's why a lot of people, they can get AL1, AL2 or PSLE. They come to secondary school, fail. Happens. I'm one example. So 89 was a prime number, was. Why is was? Should be is. So this fellow never pass English. Anyway, the one in red was not written by me. 89 is a prime number as its only factors are 1 in itself. Why is it all in past tense? Therefore, A and B are 1 and 89. Okay. No lah, but I mean, this is quite basic, isn't it? Okay. Sometimes like this, Shafi, sometimes they will give you like that. 1176 equals to 2 power 3 times 3 power P times 7 power Q. Then find the values of P and Q. So you don't just give this part. You must say, therefore P equals to 1, Q equals to 2. Can? I understand. You must understand all this. Can? Okay, now. Okay, we got 10 more minutes. Now, what is a perfect square? So a perfect square is when you have a number multiplied by itself. So example, 36 is a perfect square. 100 is a perfect square.
18.
18 is what times what? Can you have a number multiply itself to give you 18? No, so 18 is not a perfect square. So what is square root? Square root is the reverse. The reverse. So for instance, the square root of 36 is 6, the square root of 100 is 10. So what is a perfect cube? Perfect cube is when you have 3 times 3 times 3 or 7 times 7 times 7 or something times something times something. Okay, so something multiply itself 3 times, a total of 3 times. Okay, and then cube root is the reverse. So why are we learning all this? Well, because now we need to use prime factorization to go and find the square root and the cube root. So let's look at this one. Okay, so this one we're doing cube roots. Okay. Cannot. But you can check your answer using calculator. Okay, so let's look here. This is 1728. So they are asking you to use prime factorization to find the cube root of 1728. Okay, so 1728 divided by 2, 864. 864 divided by 2, I don't need to go through the whole thing. So basically your 1728 is 2 to the power of 6. Can you see that there are six twos here? 2 to the power 6 times 3 to the power 3. Now, when I apply the cube root, let's see whether you're sharp or not. What do you notice happening to the index?
6 becomes instead of 3, instead of 2, become 6.
Still, I lost. What are you saying? So, okay, 1728 is 2 to the power 6 times 3 to the power 3. Agree?
Yeah.
So, the question here is not asking for the prime factorization of 1728. The question here is asking for the cube cube root of 1728. So you need to apply the cube root here. But what do you notice happening to the indices? Indices plural of index. The 6 becomes?
2.8, 2.
The 6 becomes 2, isn't it?
Yeah.
The 3 becomes?
3.
Wait, where got 3? I'm pointing to here. I'm not pointing here, I'm pointing here. What is here?
Nothing.
It's not nothing, it's something.
Well,
Oh, 1, my friend. If the 3 is by itself, that means it's 3 to the power of 1. So what has happened to the index? From 6 it became 2. It divided itself by
3.
3. This one also divide by 3. So this is cube root. This is cube root. So when you apply a cube root, the index. Okay, so for a number to be a perfect cube, the index of each factor has to be a multiple of 3. Like, if this is 2 to the power 5, is this number going to be a cube root? Sorry, is this number going to be a cube? No. It has to be a multiple of 3. It has to be a multiple of 3. Okay, I think you try 8B lah. Then we can take a break and then let you do the test. 8B,
H.
page 7. I haven't gone through HCF and LCF with you, but I'm assuming you didn't study that on your own at home. Okay, then good luck for your test.
Question 8B.
Yes, sir. This one here.
Yes. Page 8.
Doesn't matter lah. Can you find question 8 or not? No, you need my help to find you question 8. Okay, good. Bro, I worry for you. You entering secondary school. you, you don't withdraw yourself from this class, or later I'm going to cover you.
Very nice.
Thank you. Are your parents pressuring you to do well in school? They should. Your parents are more relaxed kind. Like, I mean, any result also can. Not your mother.
No father can.
Your father can. Okay. I hope if you don't do well for this appointment, she doesn't know about it.
Means I don't hate them.
Okay, come 3375. Get me the. You can see how I did part A. You can see how I did part A. So if you can understand how I did 8A, then 8B should be a walking path. Yeah, tell you what, why don't you go and do it over here on my iPad, then I can see what you're doing. And then you do on the iPad. Can see it, you can check, no problem. So that I can enjoy my coffee and see you do it. Sit down, sit down.
Okay. What to erase?
Yes, tell you. Where's the 3375? Okay. So you divide it by, how do you first divided it by 3, eh?
Yes.
Okay, good. So can you put a 3 on top of the 3? Yes. So that, like what you see me do with the 729, so that first number has to be the original number. Okay.
One.
Okay. Then final 5 you don't need to write. Just undo that or erase that 5. Yes, okay. So 3375 equals to, or you write cube root lah, cube root 3375 below. What's your, no, you're erasing.
Oh.
You have to switch on the marker ini. Yes. Cube root, cube root the whole thing. Yes. Equals to
Oh.
the cube root.
Cube root.
Right, cube root again. Okay, so 3375 is 3 to the power of.
3 to the power of.
It cannot be 3 to the power of 4. Something is not. So here, this one here, I think this should be a 5, isn't it? So there should be 3 threes and 3 fives. Never mind, don't need to erase that. So you just write 3 to the power 3.
Wait. What was it again?
Okay, so you see here 375.
375.
You divided it by 3, you get 125.
Yeah.
But 125, you divide by 3 to get 25?
No, divide by 4.
Divide by 4.
Divide by 5.
So this should not be a 3, this should be a 5.
Right.
Okay, never mind, finish. Just leave it as it is. So you know that there should be 3 threes. Come, I show you. There should be 3 threes. Oops, and 3 fives. Okay, so this will be 3 power 3. Right, 3 power 3 inside the square root, inside the cube root.
3.
3 power 3. Where's your 3 power 3? I just see a 3 there.
Then, after that?
No. 3 power 3. 3 power 3 times 5 power 3. Okay, so what happens when you apply cube root to that? What happens to the power 3 and the power 3? Try to recall what
Power
it
6.
It becomes power.
6.
No.
Power
What happened here? So you see, look at the power 6. The power 6 here. What did the power 6 become?
9.
No. The power 6 became
2.
power 2. Remember here? Square root, this one square root. So square root 2 and 2 became 1 and 1. Square root 8 become 4. So for square root, it divided by 2. For cube root, it divided by
3.
3. Remember just now I wrote divide by 3. So for cube root, we are going to divide by 3. So if you divide by 3, what happens to the power 3?
Power 1.
So write 3. So for power 1, do I need to write power 1 there?
No, just
No. Okay, then times. So 5. The 5 also power 1, right? So what is 3 times 5?
15.
15. Okay, confirm for me with your calculator. Cube root 3375. Do you get 15? Yes?
15, yes.
Okay. Okay, sit down. Okay, last bit before I let you do the test. Okay, now if you have two numbers, okay, two numbers or more than two numbers, you can find what is known as the highest common factor or the lowest common multiple. Highest common factor or lowest common multiple. Okay, so here we have two numbers 120 and 315. Can you turn to page 10? In secondary school, they won't tell you, okay, turn to page 10. You must straight away, hey, where's my teacher? Okay, inside page 10. Faster open the page to page 10. You like, Yunda saya. We are, like you like living in Hawaii. You're living in Singapore, bro. You're fighting it out with the Manjans and the Maples and all. Again, I said something that shouldn't be recorded. But you get my point, huh? For all these scholars from overseas coming in and they're out to get your lunch, in the words of Lee Kuan Yew. They are out to get your lunch. Okay, where was I? Okay, so prime factorization, we do for both. So to find the highest common factor of two numbers, step one, do the prime factorization for both. Step one, you can see? Step two, put them together, side by side. Then, for HCF, we look for what is common. So what is common here is 3 and 5. See, I highlighted it. Is the 7 common for both? No. Is the 2 common for both? No. So ignore the 2, ignore the 7. So the HCF is 3 times 5. Why is it 3 times 5 and not 3 power 2 times 5? Because you must take the lower power. You must take the lower power for HCF. Okay, it's written over here. Multiply the lowest powers. So I told you have to read these notes. But you didn't. Never mind, it's okay. Okay, so again, now one more time. HCF, step number 1, do the prime factorization for both numbers. Step number 2, list them out like that. Step number 3, take the common factors. Okay, common factors, lowest power. Okay, this is for HCF. Okay, now for LCM, it will be slightly different. For LCM, I line them up. Same thing, I do the prime factorization. Then I line them up. But now, I will multiply everything. I will multiply everything. So, you see there's a 2 power 3 there? I have to multiply the 2 power 3. Okay, now this is common, right? 3 power 2 and 3, right? So, I multiply 3 power 2. 5 and 5, 5. 7, 7. Can you see? So, LCM is like HCF plus additional the ones that are not common. So for HCF, I would have taken 3 and 5, right? But for LCM, I'm taking 3 power 2 because I multiply the highest power times 5. Because 5 and 5, is there a highest power? There's no highest power, so just take 5. Times 7 times 2 power 3. Okay? Do me a favor, just copy this down. Copy this down. This is on the next page, the LCM page. So 120, you write 2 power 3. Done? Okay, copy the HCF one. HCF, I just need you to copy this 1, 2, 3, these 3 lines here. HCF, copy the 3 lines. Okay. So with that, put away your notes, please. Okay, write your full name. Don't have to write anything else, just your full name will do. And then go ahead and do the paper.
Cannot use calculator.
Okay, just use your calculator. It's just that when they say in the parts where they say without using a calculator, be sure to show your working. Show your working. No need class on okay. Yes, right. All the best. The aircon is okay for you?
Yeah.
Let's stop there. point 38 cent. Tapi I can share one with you. So I can be home by about 2 o'clock. So I got you. I don't know, it's up to you. Okay. Yeah, so what is it? Okay, that's it. Okay. Yeah, you support it. Yeah.
Hah?
Also, what day?
Jadi apa? Kalau mau dari sini juga, nah aku ini juga juga. Nah, tapi di semua dulu nanti juga sih ya.
Dia baru siapa?
Itu pasti, pasti.
I was scared. No, this girl. No, the president.
Ah, itu
Match.
oh. Sebelum itu dia,
Dia ke sana.
siapa sih Leslie?
I was thinking soalnya. I was not bikin kalau mereka
Ya, 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 ya.
oh
Tapi apa lu? Tapi apa lu? Nah, ini apa? Itu kalau posisi.
bisa back and change kasih aku lagi
Oh,
awalnya
dalam ada humor, humor. Jadi kita bukan chat, ya.
yes like bisa bench chest
Ini dan yang ini benar dikasih ini. Bisa ada kalau ada ke
rutin yes
sekarang sih ini dalam konteks pagi. Pagi itu siapa sih? Sebenarnya juga. Aku dari yang muda, dua puluh tiga tahun sampai yang bersyukur lebih. Ya,
bisa
ya, itu terus kedepannya lah. Dan itu semua kan,
istilah
dan tadi begitu.
kasih kita
Setelah itu, sorry, 2023, adanya was the tapi kita bukan, tapi no more sebenarnya.
ya
Jadi ada sebenarnya, ada was sebenarnya yang biasa. Pagi ya,
tapi kalau kita ya saya
kalau bisa itu, ya, jadi ya, selalu itu, ya, jadi sering bersama, sering bersama, jadi langsung ya, sering bersama,
masih kita sudah oh yes sudah ini
ini sering,
nah dengan apa
oh, kasus ini,
kasus itu resmi
oh ya, masuk, akhirnya kita masuk masuk. Tapi kasus yang terjadi dari Switzerland, kayak sama. Terus kita kira terus ini sekitar, no dari tema, aslinya itu. Kayak dulu yang tahu dari orang itu, kan dulu seperti misalnya, kalau dia seperti itu, ya, tapi sih yang jelas. There was a correction because people use
Yes,
Right.
that was true. I didn't know it. If I do correctly. Some kind of
Long-term
Yeah,
One
yeah. So that last question, you're supposed to find either the LCM or the HCF. Okay, I can give you that much information, but you have to decide based on the question. Are you looking for the LCM or the HCF? Right. Okay, if you're done, you can leave like so. You want to check? You still have about 5 minutes. Yeah, maybe just glance through a bit more. I have a class at 2:15, but I can spare you a moment. Okay, yeah, let me just close this. Okay.